that are really using space in order to help the environment. I want to thank the Ministry of Foreign Affairs, Gidon Bechar, Yael Ravi Tzadok. I want to thank the Space Agency and the hardworking folks at our ministry, the Department of Foreign Affairs. I also want to give a special thank you to the Ministry of Environmental Protection for being a great partner throughout all of this. And thank you to all the private sector folks that are here today. Thanks.
Thank you, Tom. I would like to invite Ambassador Gideon Bechar, Special Envoy for Climate Change at the Ministry of Foreign Affairs, to say a few words and host the panel. Please, Gideon.
Thank you very much, Shani, for this nice introduction. Good morning to you all. Ladies and gentlemen, colleagues, dear friends, participants at this very important COP27 here in Sharm el-Sheikh, and for all the people who are tuning in remotely. Here at the United Nations Climate Change Conference, the international community has been discussing for over 2 decades, and even more, possible ways of combating climate change and assessing the progress done in that area. More recently, the private sector has also become engaged in this cause, as we have witnessed everywhere around us, as well as here in this very conference. However, while climate change is an Earth-based problem, it does not have to only be Earth-based solutions. In fact, in the next 90 minutes, we hope to present through a very special group of panelists and speakers why space-based solutions must be relied upon to effectively mitigate and manage climate change. As most of you know, space is already an enabler of critical technologies. We use them really every day, whether location-based services, long-range communications, or imaginary and data analysis tools. It should not be surprised then that these tools can not only benefit humans, but humanity as a whole. Imagine this. If you can track your car or your phone as it is shipped to your house, why not track ships to avoid oil spills and conserve energy? If you can communicate with your family from a distance, halfway around the world, why not also educate and raise awareness in remote locations via space and satellites? And if you could monitor how many cars are in your parking lot, why can't you also monitor their gas emissions and more other things? Ladies and gentlemen, today's event is not only a learning exercise or an academic lecture, but a call for an action on both governments, private sector, and the other key stakeholders, whether international or regional or national, to expand their horizon. Space, as they say, is the final frontier. But as far as combating climate change, it should also be the next one. We would like to start this event by playing a special pre-recorded statement by the second Israeli astronaut, Eitan Stibe, who unfortunately could not make it here in person. Eitan flew in the Rakia mission this April to the International Space Station, conducting over 40 experiments in space, and is also an entrepreneur and philanthropist who is happy to share his experience, both as an astronaut as well as a private stakeholder in the space industry. So we are ready for the pre-recorded message, please.
Hello, I am Eitan Stibbe, mission specialist on the AX-1 mission to the International Space Station and Israel's second astronaut. I wish I could attend this important conference that will create new public-private partnerships and collaborations to mitigate climate change, both policies and actions. The crew on board the ISS is completely dependent on limited reserves of air, water, and food, and on each other. Traveling at 28,000 kilometers per hour around planet Earth, humanity's space station, watching its fragile atmosphere during the day and night induces the unquestionable understanding that we must all collaborate to keep it in good condition, as a commitment to all future generations. Any disaster on one continent will definitely affect the others. When my team began the mission's planning process, it was obvious to us that this mission is about much more than human spaceflight. It was our intention to inspire as many people as possible and to create long-lasting impact and measure it. In this spirit, we designed the Rakia mission as an open-source project where thousands of researchers, educators, artists, and students could develop parts of the mission and contribute to the development of Israel's space ecosystem. One of the experiments I enjoyed the most during my time on the ISS was called Ilan ES, continuing the work started nearly 20 years ago on Columbia STS-107 mission. The objective was to record lightning and transient luminous events, TLEs, from the cupola window, based on preliminary global thunderstorm forecasts. There's a strong correlation between lightning storms and global atmosphere warming. I really hope the data collected during our mission will bring to a scientific breakthrough in atmospheric studies and benefit people from all over the world. The Rakia mission was committed to helping advance the United Nations Sustainable Development Goals, SDGs. And we made 95 distinct contributions across 10 of the UN SDGs, with an emphasis on good health and well-being and quality education. We held teaching lessons about climate change from space. We helped an Israeli startup to develop cultivated meat in order to reduce the emissions of greenhouse gases and create sustainable food systems. The trend of private space exploration creates new opportunities for addressing global challenges, as space is becoming more and more accessible. I wish you all a fruitful conference and a good future for us all.
Well, thank you, Eitan, for this very remarkable speech. Next, I would like to welcome the Director of the Israeli Space Agency, Brigadier General Reserve, Mr. Uri Oron, and the Director General of the Ministry of Environmental Protection, Ms. Galit Cohen, for a panel. Please join us. In the following panel, we would like and wish to hear both from Mr. Oron and Ms. Cohen about their take on space solutions to climate change from a wide governmental perspective as well as a regional one. Do you hear me? Good. The first question is for both of you. Uri and Galit, what role does your office play in combating climate change?
You want me to
Ladies
start?
first.
All right, thank you. As a Ministry of Environmental Protection, that's most of what we're doing in the ministry. And for the climate change, now I can say definitely there is a lot of departments inside the ministries that working on mitigation issues, adaptation, and information, creating information. That is what is we are speaking here. So about the mitigation and adaptation, now there is, I think, very good institutional framework for the government to work. We have our strategy. We have goals for 2030, 2050. And this is, I know that it's very important to understand where we're going. And also now, after working with all our ministries about mitigation and strategy, and we went each one sector by sector to see what is the contribution that each sector can bring to reduce our gas emissions in Israel. And now, just a month ago, we passed also a new resolution, governmental resolution for adaptation plans. So each one of the ministry should create its strategy for adaptation climate change. And I hope that by the end of 2023, we will have a whole government approach also for adaptation. So I think it's there is an institutional framework, both sides, and I hope that we will see change very soon.
Thank you, Galit. Thank you, Gideon, and good morning, everyone. Going back to the questions about the role of the Israeli Space Agency regarding to the issue of climate challenges, I think the first one is to promote science and technology based on space to be the baseline of trying to mitigate those issues. Without promoting the science and technology, basically we'll be blind. So we need to have the knowledge and we need to have the know-how, and one of our most important things is to promote it. We are not the only one that's doing that, but from a governmental perspective, that's a major role. The second role is to help and build an ecosystem. Later on this day, we'll hear about different companies, private entities, that part of this ecosystem. If we'll have a stronger ecosystem in Israel doing space elements, we'll be much stronger. And this is another role. Another role that I would like to highlight, which is directly connected to what just Galit says, is to implement space technology in answering national problems. Most of the agencies and offices in Israel, and not only in Israel, are not aware of the potential of space to addressing their problems. This is part of our role. We need to bring it, we need to help them, we need to build solutions based on space assets. Last but not least is we cannot do it by ourselves. So we need to promote cooperations between government entities within the nation and with other countries.
Thank you very much, Galit and Uri. Uri, the next question goes also for you. So how much weight do you give to international and regional cooperation in the field of space and climate change? You started mentioning it just right now, so if you can elaborate, please, on that.
Yeah, thanks very much. It's very easy questions when you go back to what just Eitan described from his private experience. When you're looking from space down to planet Earth, you see no boundaries. When you're taking a satellite image, basically the same image that you are taking capture, for example, Israel as well as Egypt, or Israel as well as Jordan. So basically there is no boundaries. On the other hand, climate issues see no boundaries as well. drought. That's one example. Floods, and there's another examples. How to mitigate agriculture challenges, see no boundaries as well. So what we need is to combine the needs and the challenges with the opportunities that you have in space together. When you will be able to do that, then we'll be able to understand common interest. And in that regard, we understand that this is a major, major, major part of what we are doing is to do it together. It's not only, it's only because it's a nice thing to do, it's the right thing to do.
Thank you very much, Uri, and I really want to reiterate what you are saying, and both and Galit was saying as well, that we really have to work in a coordinated way, and together, only together, we can face the climate challenges. Galit, the next question is for you, and we would like to hear what is the importance of space technologies in understanding the risks of climate change and the ways to adapt that you are mentioning before.
Okay. So speaking about adaptation, and adapting climate change requires information. And the climate risk severity and frequency differ depending on the geographical location. Therefore, we need high resolution, robust knowledge and climate change exposure. Unfortunately, such information does not exist. So an efficient way to collect all the information we need is using the satellite remote sensing, and this is where the space is coming in. The resolution and the abilities of remote sensing advanced significantly over the last years from other circumstances, but it's good for us. And it is now possible to monitor a variety of information, like temperature change in remote unmonitored areas, sea level rise, real-time monitoring of natural disasters such as floods, fires, and so on. So it is very important to know that not only the risks, but also by the sensitivity to the risk and the adaptive capacity change with high spatial resolution. So therefore, for planning and implementing effective climate change adaptation plans, both local and regional governments have critical needs to those resources of information, maps that can interpret them, with the goal of optimizing decision-making across all stakeholders and use cases, from municipal planners and developing ministries and so on. We, as the Ministry of Environmental Protection, developing now risk maps. It's a portal of information that will collect all the information that we can use, and better understanding which the region, cities, communities, and even street buildings can be more and more affected by each of those aspects of climate change, and also climate-related natural hazards and so on. So our portal will include high-resolution maps of street level, modeling for climate risk exposure, including floods, urban heat islands, wildfires, sea level rise, etc. So the validity of those layers, information of those layers, is so important for us, and the information that generated by satellite remote sensing. And the portal will also include sensitivity, so it's so important information for understanding what should we do and what is our priority. Even in the middle of extreme climate event, where do we have to go? Where do we have to evacuate people? So it is important, and I think that the remote sensing, satellite remote sensing information that we can have today is enormous and so important. So we would like this collaboration so much. Thank you.
Thank you, Galit. This is really amazing. So thrilled to hear all the possibilities that you have mentioned. Uri, how do you assess the role and importance of the private sector? Now we are moving into a different area, specifically the space industry, and in this the issue of climate change, combating climate change, mitigating the effects, etc.
Thanks, but since we are sitting here live, I would like to comment. I would like to comment on what Galit says and actually highlight even strengths. But if you pay attention to what Galit just said, you see the exact way of thinking that we need in other places. It's not just talking about technology. It's talking about solutions, problems and solutions. And the portal that Galit just highlighted, this is a great example of what all of us need to do in other places. There is a problem, and part of the solutions will be based on space assets. If we'll be able to understand what each side need to bring to the table in order to have a better solution to the people of Israel in other places, that's how we're going to promote eventually the ecosystem. So we need this type of thinking, problems and solutions based on technology. And not everything will be based on space. But today, with our capabilities and the fact that access to space become more and more achievable, yes, part of the problems that we are facing, especially in climate change, could be solved through space technology. So what I'm looking for is the exact way of thinking. Problems, problem-solving patterns, and eventually solutions. So I'm just echoing and highlighting and strengthening what Galit just says, because I think it's very, very crucial. And in that regard, we are building what we call an Israeli Space Data Center that will provide exactly that. Will provide the data that is necessary to solve problems. We have a great partnership with the Ministry of Agriculture just to understand what is growing where. We'll hear a lecture about it. Today, it's much easier to understand this problem using space assets. And this is just a quick example. Going back to the private sector, but it was important to me to highlight it. The challenges are huge. There is no one that is basically on the challenge, whether it's a government entity or a private entity. And there is no a single entity that owns the solution. It's a combined effort. We must have the private sector inside this effort because they are much more agile, they are much more faster, they know how to develop things without the bureaucracy of the government. And on the other hand, the government can solve problems on a national level. But without the private entities, it is worthless. And using the private entities or bringing the private entities into this effort, it's not the right way to do it. It's the only way to do it. That's the way I understand it.
Wonderful. So you see great importance for the private sector, and you are echoing what Galit was mentioning before for the possibilities and contribution of space to the issue of combating climate change. The next question goes for both of you, Galit and Uri. To summarize, what would be a success in your mind in looking forward to COP28 in Dubai 1 year time from now? Galit, please.
Yeah. If we will sit here together in Abu Dhabi, it's not Dubai, I think, and together with us, we will have Jordan, Emirates, Egypt, Morocco, and many others, countries around us. And we won't speak about portal for Israel information. We'll speak about the regional portal, like we are now preparing for Israel with tomorrow, which they are here. The company, I was speaking about private-public partnerships, and together create a portal, a regional portal for risk maps, and together collaborate. It's not just about information, it's also about collaboration, capacity building, working together. When there is any extreme event, climate event like wildfire or something like this, or floods or something like this, then we will collaborate, our collaboration, bringing our capacity together, moving from one place to the other, like we are having with Greece in wildfires, that we help them and they are helping us. And this is what we would like to see. So if we can be next year together with our partners, with our regional neighbors on the same open table and working together, this is going to be the success.
Amazing. Thank you, Galit.
Thank you. If you didn't understand, this is an open invitation for next year. So hurry up to register. I'll try to be even more specific about the success. What we need to do is to translate words into actions. We are not there yet. In order to achieve those things, what we need to do is to have eventually projects, process, and real milestones that we can really touch and feel. So in order to be there, and this is one great example, if you have a joint project that will be founded by whoever, that's a progress. Now, you cannot measure success in this huge issue by a 1 year time frame. It's much bigger than that. But if you'll be able to sit together next year and realize that we have real projects with real funding that will move us forward, that could be a success. And in going back to the essence of this whole morning, yes, I do believe there is a huge potential in space to help and mitigate climate challenges. But in order to make it from a potential to real, we need to have actions. Thank you.
Wonderful. So this is indeed an open invitation. First of all, for you both, and for all of you next year in Dubai, where we will meet again and discuss climate change, space from a regional perspective, with the idea that we are going to make a progress on that. Am I correct?
Yeah. Exactly.
Wonderful. So thank you very much. Toda rabba. So now we are moving to our next part of the day, and this is a short presentation by 4 presenters, one after the other. Stakeholders who are doing a lot already in the field of climate change and space. So I would like to start with inviting Professor Eyal Ben-Dor, head of a remote sensing laboratory at the Tel Aviv University. Please.
Thank you very much. First of all, for the invitation and then for the introduction. I'm Eyal Ben-Dor from Tel Aviv University, Department of Earth Science and Geography. And I would like to talk about the new technology. We are doing monitoring by remote sensing. The new technology, actually, it's not that new, but it's a new technology that will gather information. And I think one we got from the panel is we need information. Then we know how to do with this information is another step. So the title is Hyperspectral. This is the technology, remote sensing from space, a powerful technology to combat climate change. So the outline of my talk will be as follows. Actually, it will be a popular science to get you into this technology. So what is hyperspectral all about? Then the added value relative to other remote sensing means we have today. Then I will talk about the 5 spheres we have today on Earth and discuss what is this technology bringing to us in these spheres. This is examples, and then I will introduce you to the 6th sphere we are not thinking of at the moment. At the end, I will also give you some introduction about the Israeli Space Agency arena and what is the plan for this technology. And then I will also tell you something about the contamination of the space. We think about contamination of the Earth, but the space is also contaminated. So I will speak about that. Take it on the back of your head, and we will see what it's all about. So hyperspectral technology is simultaneously acquisition of images in many spectrally continuous and narrow bands across or part of the optical region where the sun is shining and irradiate the Earth. So what is all this about? So each component, each target that has chemistry has its own spectral features. We know that from spectroscopy, we know it from chemistry, we know it from physics. So how it goes in space? So we have a couple of spheres, atmosphere, and we have different spectral of atmosphere. We have the lithosphere, we have different spectrum of the lithosphere, hydrosphere, and so on, biosphere and cryosphere. So each of the sphere has different spectral information, and within each sphere we have a lot of other information that related to the chemistry and physics of the material that we are monitoring. So let me just show you how it looks like. So if we are looking on multispectral, we have 4, 5, 6, 3 colors, and these 3 colors you have it is on your cell phone, and probably you can have much more. But in hyperspectral we have thousands, maybe hundreds of colors. We don't see it in our naked eyes, but these colors can be seen by a spectrometer or by a special camera. And this is information about the chemistry and physics of the objects that we are monitoring. So what people are doing, they are sending a satellite to orbit, and they are actually picking up in this spectrum what is the best area to put sensor to track after the problem they are searching. And by that, they are all the time planning sensor, planning satellites, and they are not actually covering the whole spectral region. And this is a problem. And if we look on the Rentgenolog issue, you see that we have the X-ray. X-ray gives you bonds. The CT gives you much more information, and the MRI gives you quantitative information. So let's do comparison between the hyperspectral remote sensing and the grayscale and the RGB, what we have in our cell phone. So X-ray is grayscale, CT is RGB, and hyperspectral is the MRI. We do MRI to the environment. This is how you should think. So it's much more information we get there. So we have, we can actually estimate that we know on maybe 25 of the applications. Uri mentioned that we need to find ideas. We need to find a way to go to the solution. And we are actually sitting in a place we have only 75 of the application not known. So imagine that we find an application and we now have to design a new satellite. So we have to build the satellite, we have to think about how to build the satellite, we have to put money on this satellite, and once it's in orbit, it's 5 years. So if we have hyperspectral remote sensing, we don't have to do that. It's there. We just need to configure the spectral information to our mission. So now we have the 5th sphere that I promised you. It's the cryosphere and atmosphere and the lithosphere. And I will give you some short example about each of the spheres. Let's start with the cryosphere. The hyperspectral information from satellite can give you particle size of snow. This is very important for avalanche assessing and so forth. Also, we can give you information about the status, the phase status of each of the phase in the snow. Like it's how much liquid water. It's also very important for snow avalanche. Let's go to lithosphere. Lithosphere, we can see minerals. We can detect minerals, one minerals from another. It's very important for raw materials excavation. So this is one example. And the other example is taking this information and create maps. This maps is quantitative map. It's not a qualitative map. It's quantitative map of calcite, which is one of the mineral, very important mineral for buildup, chlorite, and dolomite, and muscovite, any kind of mineral. Just to let you know that today there are people who are showing and providing, this is people from NASA, providing information about lithium. They could get lithium assessment. This is very important for the new batteries. So this is something that is very new. Hydrosphere. This is a series of images of area in Potsdam, Germany, and you have reservoir, or you have a water reservoir here. I mean, it's a natural water reservoir in each of the date. You see that with the water, this is drinking water. The drinking water is changing the quality from one year to another. So you can track about the quality of the water. Another thing, this is the Eshkol reservoir in Israel. You can see also the spectrum can define you what is the quality of the water, what do we have in the water, and many, many other things that we need to monitor and to use this reservoir for drinking water, which is very essential here in Israel. Biosphere. Biosphere is agriculture. This is an example to show you how we can track after nitrogen content deficiency in wheat crop. So we see by the color what is needed in each of the plots. Also, we can also do this. We can do the spectral analysis to find out what is the burning potential of forest. This is Yatir forest, and we can see that we have the fire fuel of this forest at the certain date of the year. So we can very much use this information to protect the forest, or at least take some precaution in the event of the fire, summertime and so forth. And it's changing, it's not stable, it's changing from one day to another. The atmosphere, a very new funding is that we can track after methane. We can track after CO2 plumes. And this is one example that is published recently in one of the papers, one of the journals, very important journal. So we can track not only after the plume, we can track after the concentration of the methane in the plume. This is also all from space. Another issue is to find out what is the dust, what is the mineralogy in the dust. This is Sahara. The left-hand image is the area in Sahara Desert, free of cloud, free of dust. The right hand is the same area with dust, and this dust has mineralogy. And by this paper that we actually published about 10 years ago, NASA initiated a project called EMIT. And EMIT is a project, hyperspectral project, that still or already in ISS, tracking after dust over the globe. What is the sources of dust? Where it goes, what are the minerals in dust, what contamination we have in dust. So this is a project that just initiated. The sensor is in ISS, and it will be work for 1 year. And we are going to get data and process this information to the benefit of mankind. But we have a forgotten phase. What is the forgotten phase? The forgotten phase is soil, is the pedosphere. We didn't have the pedosphere at all in these old spheres. So everybody is trying to monitor the Earth. Don't think about this pedosphere. Where this pedosphere goes, it goes in the middle. So it's a combination or harmonization of all the spheres together. And this is very important. Why is it so important? Because soil is critical to life on Earth. It's also a source for food security and enable life on Earth, as we said. And this is from a paper published in Guardian. So soil is very important, and we are neglecting it. And I would like to show you some example about the soil, why soil is so important for agriculture and also for environmental monitoring. One example is, this is in the Israel Valley. In Israel, you can see that we have maps of different soil attributes. This is very important for the farmer. He can take these maps and actually plan his activity. Save lots of money, save lots of water. And this is a recent image that were actually generated from the information of soil in the area of southern Israel, that's showing the erosion potential of the area based on the information of the soil, spectral information of the soil. So this is another thing very important. And one of the things that now is very highlight, and which is now all over here in the pavilions in COP27, is the CO2 sequestration. So CO2 sequestration you can monitor by the flux of income and outcome flux, but also you can monitor it by the organic carbon actually conserved in the soil. So for that, the ESA, the European Space Agency, started a project called World Soil, and this World Soil is trying to mitigate this information and to map the entire world for soil carbon stock. And by that, we can actually definitely and precisely know what is the carbon stock in each field. And if you are familiar with the term carbon credit, you can give to the farmer carbon credit about the carbon he was sequestrated to his field. I would like just to say that there are several nations that have a hyperspectral sensor in space. And one of them, you see all the space agencies that have already sensor in space, but we also have Shalom. Shalom is the new hyperspectral sensor that will be probably in space, and it's a cooperation between Italy and Israel. And this Shalom mission will actually focus also in soil. You see all the high-level product that the mission is actually targeting, and it will be soil. Not only soil, but soil will take a very major role in this project. And last but not least, I would like to speak about, you remember what I was how I start my talk about the contamination of the earth? So if we look, the contamination of the space. If you look in space, we have so many debris in space. Every high school student, every high school class sending 2 or 3 small cubes satellite to space. It's very nice, it's very good. I'm not saying it is wrong, because it is providing education to those young students, but I'm not talking about them, I'm talking about those sensors that are built for a mission. So at least don't plan to put a sensor for a mission. Plan to put 1 or 2 or maybe 10 big sensor, hyperspectral sensors that will do everything that all these small sensors will do. And by that, you will actually save our space from being contaminated with, I would say, debris that may change the climate. Because this debris is actually covering the solid earth, and they are affecting the atmosphere. Definitely affect the atmosphere, will affect the atmosphere more in the future if we are not going to preserve this issue. So need a regulation for that, and we have to think about that as well. Not only about looking from space to Earth. So I would like to sum up my talk and say that hyperspectral technology is a game changer. And the pedosphere is one of the very major sphere, and actually it's a combination of the other sphere that I just elaborate on. And there are many unknown applications where we don't know, but we will know, and once we know, we have the sensor in orbit to configure. And the Israel Space Agency plans to mount hyperspectral sensor in orbit, and this will be also something very important. We will be leaders in this technology and direction, and definitely this is the step to go. And we need to save the space, and as we try to save the Earth from contamination. With that, I would like to thank you very much for your attention.
Thank you very much, Eyal, for this really very fascinating lecture. I've really accumulated lots of information and learned a lot, especially that we do not have to use single-use satellites. Our next speaker is Miss Adina Fenton, a Partnership Director of the Windward Company. The floor is yours, please.
Hello, everybody. Hello. So today I'm going to talk to you about decarbonizing shipping and how we can reduce emissions in shipping using satellite-based data and artificial intelligence. Sorry, something wrong apparently. Here it is. So I wanted to ask with a little quiz, a little question, which is, what do all of these have in common? Not the fact that they're mostly blue. Well, actually, it's the fact that they all, at some point in their production cycle, took a voyage on a ship to get to you. And the reason why I wanted to start with this question is because oftentimes, when we speak about shipping, we don't realize how close it is to our daily lives. We don't actually understand that this is a critical part of everything we interact with every day. And why? Because 90% of global trade transits through the sea. So actually everything in our lives, from the concrete of our homes, to the cars we drive to work, to the coffee you drink, to the clothes you're wearing, transits through the sea. And you can see, for instance, in the label of your shirt, where your shirt came from, and this is only the last part of the journey of your shirt to get to you. So today, shipping accounts for about 3% of all logistics emissions and 3% of all global world emissions. And this is projected to triple by 2050 if we don't start to improve it. And actually, in order to improve it, the first step, I believe, is to start measuring it accurately. And why? Because if you cannot measure it, you cannot improve it. And what is not improved will always degrade. And this is a quote from Lord Kelvin, who knows a thing or two in temperatures because he's actually the inventor of the thermometer. So today, the industry has a way of measuring itself. It's called the Noon Reports. The Noon Reports is a very great technology. It actually goes like that. On a ship, you have a chief engineer, and every day at noon, hence the name Noon Reports, he goes to the engine room with his sound, puts a probe inside the engine, and measures the amount of fuel that's left and the amount of fuel that was consumed. Now here what you can see is a straight line. Actually a boat moves. So this straight line is also a moving line. And then from the engine room, which is very noisy, very hot, takes his phone, calls the master of the ship, and tells him, reports that value. The master of the ship then writes it down manually, sends that to the ship owner, who then sends it to the charterer, and then you can imagine how this works as a broken phone and the quality and accuracy of the data that you can get from such a methodology. And this is where we believe that the power of big data and AI can be a game changer in how we measure fuel consumption and carbon emissions in shipping. So, hi, my name is Adina. I'm a partnership director at Windward. I'm also a maritime domain expert. And in the past 6 years, I've been working at this amazing company called Windward, which actually harnesses data that's coming from satellites, AIS data. It's positional data that's transmitted by vessels for the past 10 years. Originally, vessels were transmitting their positional data for safety reasons in order to avoid collisions. And we have used this data in order to create different models of risks at sea based on behavioral analysis. So we did that for security risk, basically assessing the risk of a vessel to be involved in criminal activities, things like drug trafficking, weapon trafficking, human trafficking, based on its pattern of behavior. We did that for safety, so we're predicting the risk of a vessel to be involved in an accident in the future based on the way it behaves, exactly like for cars. If you're driving fast, if you're driving more at night, you're more at risk of being involved in accidents. We did it for compliance, so we're assessing the risk of a vessel to be involved in sanctions evasion practices. And more recently, we started to be involved more in environment and fuel consumption. And why? Because there is a demand. So in the past few years, more and more of our customers have been turning to us asking for guidance on how to implement a decarbonization strategy. And the most challenging part in implementing the strategy is to understand where you're at right now and how to measure yourself. And there is really an issue with visibility in the world of carbon emissions. And actually, there have been some ways to incentivize shipping to decarbonize that have been implemented by the regulator, for instance, by asking banks to provide visibility on the deals they finance. However, the further you are away from the ship, the harder it is to get the necessary data in order to understand the vessel's emissions. Now, a vessel is a huge vehicle. So just to give you an order of magnitude, the Evergreen, the vessel that was stuck in the Suez Canal, was a 400-meter long vessel. This is the size, it's a slightly bigger even, of the Empire State Building. So ships can be the size of the Empire State Building, and in order to move a vessel that big, you need a lot of fuel. A VLCC, a very large crude carrier, can use up to 100 tons of fuel a day. 100 tons of fuel a day, it's 300 tons of carbon emissions. And just to give you, to visualize what is a ton of carbon emission, so a ton of carbon dioxide is the volume of a 3-floor house, and it's actually also the quantity that you need to power a household in electricity for 7 months. And a big ship can use 300 of these every day. There are 100,000 merchant ships in the world fleet today. And in order to absorb 1 ton of carbon, you will need 50 grown trees for 1 year. And this is 1 ton of carbon. One ship can emit 300 of these in a day. So everybody understands that this is an issue, and the industry is very willing to decarbonize, also because of carbon levies and carbon credits and taxes that are going to be put in place, and they think that if they're ready, they can avoid this cost. However, today the road to net zero for the shipping industry is twofold. So either you build new sustainable ships, great. However, you need to replace the full world fleet, that 100,000 ships that can be the size of the Empire State Building. And you have only so many shipyards that can build them. So this is going to take a lot of time to do. And also it might be more polluting than what the ships actually pollute today. The other strategy is shifting to greener fuels. So the industry has been told, use biofuels, use LNG, use ammonia, whatever. Nobody knows really what is the fuel that the shipping industry needs to use, because the alternative fuels are very expensive and they're not sufficient today to fuel the full industry. And actually, these two strategies kind of block one another, because until you solve the fuel type, you cannot start building the ships, because you don't know on what fuel these ships are going to be running. So there is a third way, which we believe can be a game changer, which is starting by optimizing your commercial decisions and operation. And this is something that you can start doing today. You don't need to wait 10, 15 years. And it is estimated only by optimizing the commercial decisions and operations, the industry could reduce by 20 to 40% its current emissions. And why? Because when you select a ship for a trip, there are many things that come into account that impacts its carbon emissions. First of all, the selection of the vessel itself. So you have a cargo you need to pass, you have a few vessels you can put it on. If you gain visibility on the actual past performance of the ships you're offered and on the carbon emissions of the ships you're offered, you can select the better performing actor for the trip. And then, once the trip begins, this is not the end of the optimizations you can make. Many factors actually have a great impact on the emissions of that ship. Things like change in water temperature. So if a ship sails in tropical waters, for instance, there's going to be a phenomenon called hull fouling, which is basically shells and barnacles sticking to the hull and impacting its performance. On the other hand, if you do maintenance, you clean the hull, then the performance will improve. Things like bad weather, hello tomorrow, really impact the fuel consumption and carbon emissions of the ship. Think about it. If you have the wind going on your face, you're going to take much more effort in order to move forward than if it's coming to your back and pushing you forward. So all of these have a great impact on how the fuel consumption and carbon emissions of vessels work. And actually, why is this important? Because when you look at what drives fuel consumption, you realize that they're mostly dynamic parameters. So over 50% of a vessel consumption is impacted by its speed, 15.1% by the impact of weather, 16% by hull fouling, which we mentioned, 9% by the draft, meaning how full the vessel is, and only 3% by vessel specs, meaning that if you have two identical ships and they sail totally differently, they will have totally different performance in terms of carbon emissions and fuel consumption. So now the issue is that there are existing frameworks that come to assess emissions for vessel. Take, for example, the GLEC framework, the Global Logistics Emission Center. Their framework will try to assess carbon emission of ships by taking average values. So if you take a trip from Fujairah to Piraeus, you will see that for the GLEC, this is an average value of distance. They will take the service speed, and they will this way give you an assessment of the carbon emissions. However, the issue is that no two journeys are identical. Take those two vessels. They took a trip from the same two ports, but one is making different port calls. It takes him 28 days to make the trip. The other one takes a different journey. It takes him 41 days. It has no sense to assess that these two vessels will emit the same. But this is what will happen if you base your estimation on a framework that doesn't take into account all of the dynamic parameters. And the issue with that is as companies are expected to show progress in their emissions, right? And the only way that they have to measure their progress currently is that. However, if they take an alternate route or they choose better ships, it will not reflect in their carbon calculation. And then they won't be able to know what's the impact of the decisions they took on the actual emissions. And therefore, they won't be able to take educated decisions moving forward. So we at Windward have trained a model based on AI that takes into account all of these dynamic parameters, the actual speed, the actual voyage, the actual specs, the actual weather conditions, etc., in order to assess what a vessel is consuming at every given point in time. This enables companies and also actors like financial institutions and regulators to be able to gain full visibility totally independently from any type of reporting or sensors on board on the emissions and fuel consumption of any vessel on an ongoing basis and historical basis. These are the results of the model. As you can see, the diagonal line figures a perfect prediction, and all of the dots, the red dots and the blue dots, are our actual predictions. Bottom line, we have made also external and internal validation tests, and our model is currently assessing carbon emissions and fuel consumption at a 95% degree of accuracy, which is more than enough in order to be able to manage your emissions and your reduction strategy. So what do we need now? I think we need to understand that decarbonization is a zero-sum game, so basically if we fail, there's going to be no winner. So it's time to share data. not only in the shipping industry, in every industry, stakeholders have valuable data that can enable the building of such models that can then enable to manage and measure more accurately the emissions. Secondly, we need to trust AI. There is a bit of reluctance in using model data as opposed to using sounding data that you take from the ship, but sometimes you need to understand that model data can be more accurate. And lastly, we need to demand accuracy because it's possible, because it's available, and because this is the only way that we can actually measure ourselves and start optimizing our emissions. Thank you very much.
Thank you very much, Adina, for this fascinating presentation. We have two more speakers, so I would like you really to stick to timetables because we have to finish at 12 o'clock. So our next speaker is Alex Silberklang, a co-founder of CTO, Terra Space Lab. Please.
Okay, hello everyone, thank you. So you just mentioned before, Ori, and you mentioned that you are looking for solutions, and you talk about data. So in TSL, we took it one step forward. Okay. Okay, so in TSL, we take it one step forward, and we have a solution that drives actions, meaning we have solutions for something which happens now and requires action now, not only waiting for a long term. So, forward. And we start with wildfires. As we know, wildfires create huge environmental damage and huge economic impact. Just in 21, we had like 23 million acres burned globally, which is 4 times the size of Israel. It's a huge area. We have an issue of air pollution, we have floods, and one item which may not be very well known, like 15% of global carbon emission comes from wildfires. It's changing, something between 10 and 20, but it's changing over time. Also, the economic impact is huge. It's like $120 billion damage in 21. If we take one case in California, that in 2017 and 18, there were 2 wildfires, and there have been like 130 people died in those fires, and a huge area burned. There was one common item to those fires. It was caused by poor maintenance of the electric company, and the company was liable for damage and had to pay like $30 billion, and the company simply bankrupted. There was later a settlement, but it's huge impact. So if there is one sentence I want you to remember from this presentation is that many wildfires could be avoided if it had been detected on time. And obviously suppressed later on, immediately and not waiting for that. And you will hear the word early detection, you will hear many times along this presentation. So why it is so important? Fire always starts small, and actually 98 or 99% of fires are discovered and reported on time, and just firefighters come, they put it out, and we don't hear about it, and we hear nothing about it. What does happen that those very few wildfires which are not detected on time, they grow over time, and before firefighters are coming, then it becomes a huge fire. If we take data from the Department of Agriculture in USA, like 2% of fires cause 80% of the cost of suppression. So those very few fires are those that we are talking about, and not the regular fires which we don't even hear about. So what is needed to detect fire from space? Obviously, we need infrared sensor. Eyal talked about that before. So we need those multispectral sensors. But we need to have two main parameters to detect fire. It must be small. We must detect fire which is small enough, and we must detect it fast enough. And if we look today, what is available today, we have all those satellites today. We have two types. We have the geostationary satellites and the low altitude satellites. The geosatellites, they provide very quick response, like 5 to 10 minutes. But the fire that they can detect is in the size of a football field, too big. And there is no way today with current technology to detect smaller fire by those satellites. If you took the LEO satellites, like the NOAA satellites, they can detect smaller area with the size of basketball field, but they do it like every 12 or 24 hours. This is too late for fire detection. Actually, you can find, even NASA has a site, you can find a map of all the fires globally. You can today look into the NASA site. You have a map of all active fires. They provide data about existing fires. They don't provide warning. So our goal is to have something which does both. Can detect very small fire, like the size of a single tree, and do it in less than 30 minutes. That's the challenge we are talking about, and we believe the technology can do it. And once you do it, obviously you need immediate warning to whoever has to get this data. Moreover, just having the satellite providing image every 30 minutes, it's very effective for situational awareness to help the firefighters know what they are doing. And it's very affordable. I will mention it later on. So basically what we do, we have satellite which is scanning the Earth and covering very wide area, unlike regular satellites. And one very small satellite can cover area which is 10 times what is the size of what we can get with regular satellites. And obviously, once a fire is detected, you get. It's not going on. That's one. Okay, so I will continue with the technology. We are talking about very small nanosatellite, which is less than 10 kilograms. The satellite itself today is almost a commodity. You can buy regular satellites. But the work is done on the payload that you see on the left side. And the payload is rotating all the time to provide the scanning. Now there are three major technologies over there. There is a multispectral infrared sensor, not hyperspectral, but multispectral is good enough for fire. And it can detect a very small fire. It is doing the self-scanning, so the scanning is done without affecting the satellite. So you can put the scanner on any satellite, and it's doing the same job. So you achieve very short revisit time at low cost. And obviously, if you want to provide immediate warning, you must have the processing on board. And obviously, the keyword AI must be here as well. I mean, everybody is doing AI today. I will mention it also, but obviously, it's not only AI, it's also some parametric algorithms. So once you have this technology, you can do much more. Just imagine that you have the data from those dedicated satellites, but you can also use data from other satellites today. And you may have an application which can do many time-critical services. So anything which has to do with action, with warning to drive action, and you can think about many things, like detecting oil spills in the ocean, plastics in the ocean, or finding, even you discussed about methane, but methane, if you want to discover it now, and you want to know where it comes from, you can use this system. So with that, I will just summarize with the same thing I said before, that most fires, or big part of fires, could be avoided if we had warning on time. Thank you.
Thank you very much, Alex, for these very interesting solutions that you have presented. Alex from Terra Space Lab. I now have the pleasure of inviting Ms. Georgina Campbell-Flatter, Executive Director of Tomorrow Now. So the floor is yours.
Good morning, everybody. I feel like we've been in this room for a little while. Can you guys just stand up for me? I need everybody's attention. Stretch, please. Yep. Excellent. All right, I need everyone's attention here because what I'm just about to say and talk about, exactly, is really important, and I want everyone's full attention. Okay, so my name is Georgina. I am the executive director, co-founder of a non-profit called tomorrownow.org. We are a non-profit. We leverage transformational philanthropy to connect next generation weather and climate technologies with communities in need. And I actually have in this room today representatives of exactly the purpose behind Tomorrow Now, some phenomenal weather innovators, and also my colleague Ronald at the back there. So to point you out, Ronald. Ronald is joining us from Kenya. He leads, along with a couple of other team members, our work in East Africa, where we're building the public and the private partnerships to ensure that the phenomenal potential of space technology is unlocked for communities that are most in need. Okay, so I have 3 key themes and messages that I want to touch on today. The first, which seems to have been flipped in this presentation, is weather, right? I want to amplify the role of weather in the climate conversation. Now, this might seem strange to you, but weather variability and weather extremes are at the heart of suffering. It's at the heart of suffering and the lack of opportunity that's triggered by climate change. And weather variability requires weather innovation for us to manage that risk. And so we need the attention just as much on climate innovation as we do on weather innovation. And I'll help you understand why. We're in a space-based panel here, and I want to get everyone excited about a very specific space technology that is literally transforming our ability to monitor weather and manage climate risk and weather risk in regions and communities that are least equipped to mitigate climate change, but are also the most impacted. And finally, I wanted to share not just innovation that is based in technology, but innovation that's based in approach. And this kind of builds on some of the comments from the earlier panels, that it's around partnership, and it's innovative partnerships that are actually going to help us ensure that the phenomenal potential of this technology is going to reach the communities who are most in need. Okay, so I'm going to ground us all in a little bit of science here, so bear with me, okay? Because I think understanding this scientific connection between weather and climate will really emphasize the seriousness of what's happening on our planet, and especially in the tropics. Okay, so is anyone a meteorologist here? Earth scientist? Right. So do you see this? Do you see this this band here? This band of clouds? Okay, that's called the ITCZ zone. Okay, the reason that band of clouds is there is because that is where the sun's rays hit most directly, right? Because it's close to the equator, which makes sense. And it moves north and south of the equator, depending on the time of year, because the Earth is tilted, right? This band of clouds is not just clouds, right? It's storms, it's rain, it's lightning, okay? Why is it there? Because think about it, right? You've got the sun's rays hitting the Earth, hot air rises, okay? We all know that. Hot air rises, it reaches the cooler parts of the atmosphere, it then condenses and it rains. And right here, where there's a lot of energy, it rains hard, okay? The other reason I'm pointing this out, okay, is because it doesn't just rain, it creates this circulation of air, or wind, okay? Why? Because if you think about it, air is heavy. When it rises, you create low pressure areas, okay? And then what you see is that air circulation has to come down. And it actually comes down about 30 degrees north and south of the equator, okay? When air rises, low pressure zone comes back down, what happens? It creates high pressure zones, here and here, right? And you don't need to know anything but the fact that high pressure zones means dry, okay? High pressure, dry, which is why you get north and south of the equator, about 30 degrees, you get desert, right? The Sahara Desert and the Kalahari Desert, right here, okay? Dry. Now, why am I telling you all of this? Because climate change, this system is sensitive, okay? And climate change, and even just a small increase in temperature, really messes with the system, and that's what's causing the weather variability and the weather extremes, okay? This band here is getting larger. They predicted this years ago. It's now getting larger, and we have evidence of that, okay? Not only that, this band is expanding. This wind and the trade winds that flow between the high and the low pressure towards the equator, they're getting stronger, okay? They're getting stronger, which is why, what are we seeing? We're seeing more intense hail, we're seeing stronger winds, we're seeing more flooding, and of course, we're seeing longer drought periods in different parts of the planet. Now, just in Africa alone, in this tropic zone, there is a billion, almost a billion people, okay? A billion people who are right now suffering from the consequences of weather variability. And we need to act now in order to do something about it. And it really is happening now, okay? And here's some data to show that. On the right here, I don't know if you can see because of the white screen, but on the right here, what you see is what's happening in South Sudan. This is over a couple of decades, and you can see that rain and the weather in South Sudan has almost doubled, okay? Doubled over the last 2 decades. In Kenya, which is only 1,500 kilometers distance from South Sudan, you've got dry. It's got more dry, okay? And you can see that here. 2006, over the last 2 decades, we see it in the news every day, right? That Kenya's has faced multiple drought seasons over the last decade. Now, how does this impact farmers on the ground? Because I think it's really important to grab, right? That's the science, that's what's happening. It's happening now, we need to do something about it. How does it impact people like Leah, okay? This is Leah, she's been working with us she's in Kenya, she's from a town just north of Nairobi. Okay, Leah is what I would call, a stereotypical, phenomenally talented smallholder farmer in Kenya. Okay, she actually has 2 plots of land. She has 1 plot of land that's close to a river, and she grows chilies there. She grows chilies so she can grow them and sell them, and she uses the profits that she makes to send her child, or children, she's got 2, to school, okay? The second plot of land is closer to home, and she grows mostly beans and maize. And that she probably is able to produce about 80% of the food that she then feeds her family for the whole year, okay? Now this, over here, is what Leah experienced in terms of weather variability last year, okay? So this is April, this is January, okay? There's 2 rainy seasons in Kenya, or 2 growing seasons, okay? In March, she saw, this is the it's always best practice, right, when you're showing a graph to show you what's happening. This orange line is basically the long-term normal. It's basically the average temperature over about a decade, okay? So this is what Leia is expecting to happen, okay? The blue lines is what actually happened last year, okay? So in April, she saw more rain than she ever has seen before. Her chili fields flooded. She didn't send her child to school that year. I mean, that's how serious it is for farmers like Leia. In September, what she expected was to plant in October. That's what the static crop calendars are telling her. She also determines when to plant by looking, there's a certain bird that migrates at that time. There's also a certain tree that flowers that they've been using for hundreds of years to determine when to plant. Well, those nature-based signals aren't working anymore, okay? So what happened is she plants here, but it remains dry for another 2 months, and she basically gets zero germination of her seeds, which is the food that she's supposed to grow for her family, okay? So what's happened? So the reason why I'm telling you this is because when I ask Leia, what can we do, okay? What can we do to help you? And what she says is, well, clearly without information, there's very little we can do. But if we can get her better weather information, weather intelligence, what can we do? Well, in this season, if she knew even just 1 or 2 days before that she was expecting a flood, but then she could pay people in her community to dig trenches in her chili farm so the water from the river will run through and it won't flood. But she can't justify that money unless she absolutely knows that it's going to rain. This, in the dry season, what she can do is she can either she can choose to plant different crops, short season crops that don't require as much water, or if she knows exactly when when the season's going to start and she knows she can guarantee the amount of rain, then she can confidently plant some of the higher yield crops. Now, the good news, okay, is that we are very, very close to being able to provide Leah and the 500 million smallholder farmers with that high accuracy, location-based agricultural advisory based on the weather forecasts. And here's how, okay? So this is an example text message that's going out to about 1 million farmers today due to leveraging some space-based technology as well as some innovative partnerships, okay? Good rain's expected in the short-term forecast, it's time to plant. On the right here, you can see a very high-resolution weather forecast that's driving the intelligence behind this text message. Now, there's 2 important things I want you to see here, okay? This square here, this black square, is about 27 kilometers. Okay, that's the resolution of the weather data that's available today, okay? But look at the variability within that 27-kilometer square, okay? You've got 112 millimeters of rain expected here, 50 millimeters of rain here. So this text message is actually only being sent to these farmers over here. And by the way, these dots represent the farmers who are currently receiving this kind of intelligence. The pink and the green, the pink and the orange represent male and female, so we're sending these messages to over 50% of the farmers here are women. The other thing that I wanted to point out is access, okay? Because this data is coming through tomorrow.io through an API. And it might seem simple, but that means that API is being utilized by farmer-facing organizations, and in this case, the Kenyan government, to be able to generate and automate these processes and then add on their own crop decision trees and innovations to help create these localized solutions. Now, I want to emphasize that there are 2 key reasons behind what is happening here, okay? One is transformative technology, and the second is transformative partnership. So why transformative technology? Why is transformative technology and why is space-based technology important, okay? Well, this here, what you can see here is that the world is representative and signals the fact that the world is blind, 2/3 of the world is blind to high-quality weather infrastructure that can generate these kinds of forecasts. When you're monitoring and communicating a weather forecast, you need to observe the weather, you need to model and forecast the weather, and then you need to disseminate the weather. In Africa, for example, most people have a mobile phone today, at least an SMS-based mobile phone. So the dissemination problem is basically solved, okay? Tomorrow.io has been innovating in models and forecasts to be able to produce that 3.54 kilometer resolution forecast you just saw in my previous slide. Now, there's clearly huge innovation that needs to happen in observations in order to really fix and solve this problem for 2/3 of the world. And the reason behind this is complicated. I'm not going to go into that because of time. But what I will say, it's because of cost and it's because of complexity, both of which can be solved through private sector innovation. What I will also say, though, is the good news is it's really important to recognize here that there are strong commitments and recognition from many, many African leaders on the importance of improving hydromet weather systems across the continent, okay? What is also important to recognize is the challenges and the reasons that we haven't been able to get and solve this problem to date, okay? The first reason is budgets. The government publicly available budgets for weather forecasting across the continent are about 25 times less than what you would see in a developed nation. What we also see is the limitations behind I'm almost at my 15 partners. That's why we need to bring in the private sector, and we need to bring in the NGOs to facilitate that, because we have to enable this impact beyond the funding cycles of short-term development projects. So I haven't had an opportunity to celebrate the phenomenal weather innovations that's happening at Tomorrow.io. Hopefully you saw the talk yesterday. But what I will say here is this is a constellation of satellites that is taking a 3D picture of the atmosphere every 3 to 4 hours. Now, this is going to absolutely transform how we monitor and forecast weather in the future. And by the way, it's at 160th the cost of existing best-in-class weather satellite systems today. This is the team behind the project. The reason why I'm showing you this picture is not necessarily, but one, to say it's real, it's cool, it's a satellite, but it's also to represent this idea that the private sector can move really fast. It's really important to recognize that their first satellites are going up in February. Immediately, farmers in Africa will be benefiting from this satellite data immediately, because we've laid the infrastructure for that to happen. And within 3 years, the whole thing is going to be operationalized and having global impact. So my final kind of couple of points here. One is that, like I said, it's not just transformational technology that makes a difference, it's transformational partnerships. And this is the transformational team of partners that are really driving the East Africa project. We've got here a team from CalRO, the Kenyan government, and over here the Tomorrow.io team and the Tomorrow Now team, and over here a whole collection of partners are going to help scale this innovation for digital agricultural services across the globe. The role of Tomorrow Now, the organization I represent, is we're the glue, okay? We're the glue among all those partners, but we're also the voice. We also amplify the voice of women, who, by the way, are disproportionately impacted by climate change, and also to champion the youth, because they're the future of climate action. Final slide. But this ties it back to why we're all here, right? The SDGs, the UN Sustainable Development Goals, okay? Hopefully, I've given you a sense here of the importance of weather-based, satellite-based technology for tackling zero hunger, okay? SDG 2. But let's also remember that the impact of weather intelligence transcends all the SDGs, whether it's health and well-being and helping malaria efforts on the ground, or whether it's renewable energy and helping determine where and how to manage renewable assets around the world. And of course, zero poverty, number one, right? That's the number one goal we all have. Weather drives people into poverty. Weather solutions, weather innovations can lift people out. So thank you.
Fascinating. As a former ambassador in Senegal who worked years in agricultural development in Africa, I can really appreciate what you are doing. And really, we have to put you in connection with our African people and international aid development people. There is lots of synergies to create here. So just to say that this was really a series of amazing panels. We see the huge potential of harnessing the capacity of space and satellites in combating climate change, regionally, internationally. And I would like and have the honor to invite Mr. Uri Oron, Brigadier General Reserve, the head of the Israeli Space Agency, for short closing remarks. Please.
Thanks, Gideon. No way I will be able to compete the energy of Georgia. And actually, there is no way that I can conclude those presentations, because we put you guys and girls into a very limited time telling your story. But what we've tried to do here today is basically to put on this very, very important stage of COP, as well as COP27, as well as the Israeli pavilion in the COP27. We want to put on the stage space, because we do believe that space could drive solutions to one of the most important challenges that all of us have. So what we've done today, this morning, first of all, we tried to look from a different perspective about the potential of space. We look at it from a government perspective, as well as from a private perspective, what Eitan Steve had just told us. And then we want to present a very, very quick and short presentations of what we call the Startup Nation, or the innovation that we already have in Israel, combining our innovation, our technology, into space assets, into space solutions. And those were very quick presentation, but I think and I do believe that we have the opportunity to connect the dots, to connect the understanding of the needs and the government actions that need to be done with the already proven potential of the technology based on space already invented in Israel. And with that, I would like to thank very much, first of all, to you, Gideon, for hosting this this morning, and the Ministry of Foreign Affairs, to you, Shani, for what you've done arranging this forum, and to all of you, the presenters of this morning. I hope and I think it was a very, very fruitful morning. Thanks very much, and have a great conference and great day. Thank you.